All right, so we want to look at the derivative of an exponential function. All right, now let's look at our exponential function. One point I want to make as far as notation goes is your book will use this notation here. Instead of writing it as e to the x, they'll actually put exponential of x. And it's just understood that when you have that, the base of your exponential is e. Okay? Now, obviously, e is not the only base that we can have an exponential for, and we will look at how to handle those. Okay? But let's just remember a few things about our exponential functions. All right? First of all, they always pass through the point 0, 1. Okay, unless it's shifted up or down or whatever, but they're going to pass through the point 0, 1. Okay, there is an asymptote on one side that at the x-axis. Okay, and it's going to be above the x-axis. In other words, the range is that y is greater than 0. Okay? Just a couple things to kind of refresh our memories about what the exponential function is. The rule for the derivative is not a typo, but if f of x is e to the x, then f prime of x is e to the x. Okay? I told you this one was the easiest one, except maybe the constant, because the derivative of the exponential is the exponential. Okay? So, really, the challenge comes when there are variations on this function. Okay? This one is its own derivative. So guess what the slope is here at when x is 0? The slope is 1. Okay? Another point on the graph is 1e. Okay? Well, guess what the slope is when x is 1? It's e. It's e to the first, e. Okay? So that's kind of an interesting observation here. Where it can be a challenge, though, is when we have a function within the exponent of our exponential. Okay? The derivative of e to the x is e to the x. However, if we have e of this function f of x, what do we have to use? What is this telling us to do?
The chain rule?
The chain rule. It's going to be e to the f of x. But then we need to multiply it by f prime of x. Okay? So all of our other rules still apply, but we will often have to use the chain rule here. Okay? So let's think this one through. All right. If I want to find dy dx for 2 times e to the x plus e to the negative 3x, here it's just a constant multiple. So what's the derivative of 2e to the x going to be? Yes, 2e to the x. All right? The derivative of 2e to the x is 2e to the x. Okay? Here, though, notice it's not just e to the x. It's e to a function of x. All right? So, we have e to the negative 3x. Notice, just like every other time we used our chain rule, when you take the derivative of the outer function in this case is e to a power, it's e to that same power. But, what do we have to multiply it by? Negative 3. What's the derivative of negative 3x? It's negative 3. So, this is minus 3 e to the negative 3x. that make sense?
Okay.
This applies when we're doing the product rule and quotient rule as well. Okay? Let's start here with one with the product rule. U is our x squared. V is e to the negative x. So u prime is 2x. What's v prime? E to the negative x times negative 1. Good. So negative e to the negative x. Okay. This is a harder one sometimes to see that you, or to remember that you've got to do the chain rule with. Okay. All right. So now here's our product rule. dy dx is u prime v plus uv prime. Okay, u prime, 2x, v, e to the negative x, plus u, x squared, times v prime, negative e to the negative x. And one thing that you can do with these is you could factor it out a little bit, okay? We have a 2x e to the negative x minus x squared e to the negative x. There we go. So what we can do, again, I don't want to end up with negative exponents, okay, in our final answer. So what we could do here is we could factor out an x and the e to the negative x. And in the parentheses, all that would be left would be a 2 minus x. Okay? And then we could rewrite that as x over e to the x times 2 minus x. Now, why would we want to factor that? Remember, eventually we're going to want to figure out when these equal 0. So if it's factored out like this, I can tell right now, hey, this derivative is going to be 0 at 0 and 2. Okay? I don't need to worry about a domain here because e to any power, remember our range, it's always greater than 0, so I don't need to worry about my denominator becoming 0 ever. Okay?
Mm-hmm.
So I know I'm going to have zeros at 0 and 2, and that'll be helpful later. Okay? Here's another one where we'd have to use the quotient rule. Okay? U is e to the 2x. V is x. So u prime is what?
Two e to the
times 2.
2e to the
x. 2x.
2x.
Gotcha.
Okay? That e to the whatever stays the same, and it's just times whatever the derivative of the exponent is. Okay? Then we have to use the quotient rule. Why don't you try to go ahead and try to finish that off?
minus 2e 2x. Are you supposed to subtract from the exponent?
Well, that's if it's x to a power. That's what this whole unit is about. It's not x to a power, it's e to a power. And the variable is in the power. Okay? Don't treat this like x to the r and make it like x e to the x minus 1 or something like that. Okay? Here it's all based on the fact that the derivative of e to the x is e to the x. So here we're using the chain rule. Okay? Where we have e to the, we have overlapping, e to the u, and then u is that 2x. So we've got to do this times the derivative of that 2x. Okay? Okay. Now, there are others that we have the chain rule. We could have this inside the chain rule. Okay? Here, dy dx, it's going to be 3 times this, now squared, but times the derivative of the inside. The derivative of the inside is just e to the x. Okay? Here it gets really interesting. Alright? Check this out. I would not use the quotient rule. I would do this. I would make it 2e to the negative x plus 1 to the negative 1/2. Okay? Rather than using the quotient rule, since there's just a 1 in the numerator, that's what I would do. Okay? So then when I do dy dx, we have a negative 1/2 times 2e to the negative x plus 1 to the negative 3/2. There's the derivative of the outer function. But watch when I do the derivative of the inner function, okay? We're doing the chain rule, but then when I do the derivative of the inner function, guess what I have to do again? The chain rule. Okay, the derivative of 2e to the negative x plus 1, the plus 1 is 0, so that's easy. I have 2 times e to the negative x times negative 1. So I'm doing the chain rule inside doing the chain rule. Okay? This is where it gets fun. Okay? So then we have some simplifying to do. Okay, the negatives will cancel, the 2's will cancel, that's kind of nice. Alright? And check it out, everything here has a negative exponent, so I'm going to have 1 over and e to the x times 2e to the negative x plus 1 to the 3/2 power. Okay, and that's as far as I would go. Alright? So, it's interesting. Alright? Alright. Have a good weekend, guys.
Thank you too. Take care.
Thanks.
What's that?